Now I'll go through a few examples of differential equations and their domains. Now I am assuming that you already know how to solve differential equations, so I'm not going to solve them for you. If you don't understand how to get the solution, please stop, try to figure it out yourselves, and if you still don't know, post a message on the discussion board. Right, so here is my first example. The solution, the domain of the right hand side is the whole plane. The solution makes sense for all values of t, so which means that the domain is the whole real line. Here is my next example. So notice that the right hand side of my differential equation has no restriction on t, so which kind of may hint you that since there is no restriction on t in the right hand side of the differential equation, then maybe you expect that there is not going to be any restriction on t in the solution. But look at this. So if you try to calculate the solution, then you see that there is a division by t minus 10, so which means that t cannot be equal to 10. Well, further, if t cannot be equal to 10, recall that the domain of a solution of a differential equation must be always an interval. Since t cannot be 10, you have two candidates. So one is from minus infinity to 10, and another candidate is from 10 to infinity. But you also know that y of 0 is 1. It means that this is the initial value of t. So the initial value of t is 0. And the initial value of t, of course, must be in the domain. So the point, so what it tells you besides specifying the initial condition is that the point 0, t is 0 and y is 1, belongs to the domain. But when t equals 0, among the two intervals, this one does not contain it, but this one does. So hence, the domain has to be the interval from minus infinity to 10. So, and in other words, what we observe here is that the initial value is y of 0 is 1, so it is here. So the solution that goes through this point, it kind of, informally speaking, it reaches infinity in finite time. So it never go beyond this line. So it just goes to infinity when t approaches 10. Alright, one more example. Here, the initial value problem cannot be really solved explicitly, but what we know is that we have two equilibrium solutions here, y equals 20 and y equals 110. And of course, any solution cannot just leave this area when y is between 20 and 110, because if it left this area, it would mean that it would have to at some point intersect these horizontal lines, which is not allowed, because if it intersected this horizontal line, and at the point of intersection the derivative would be not 0, so which is not consistent with the differential equation. But if our solution cannot leave these two lines, so it means that it cannot reach infinity. And if it cannot reach infinity, of course, it has to extend all the way to infinity. I mean, the t can be from minus infinity to plus infinity on both sides. Alright.